Welcome back, everybody. I'm putting a video together here to work through a programming challenge, and this video corresponds to the second chapter in your book on input, processing, and output. And what I want to do here is just run through an example of taking a story problem and creating an algorithm and an IPO chart, and then actually writing it up in Free Basic. I keep saying Free Basic, I mean Small Basic, so that you can see an example from start to end. By the way, sometimes I'll say Free Basic because we used to use a Free Basic, and there actually is such a thing out there. And Free Basic is not the same as Small Basic. But if I ever do that and say the wrong version, forgive me for that. Every time I say it, I really mean Small Basic. I should probably just say Basic and leave it at that. But whatever. Okay, so the programming challenge we're going to deal with here, we'll just do something really simple. Calculate the gas mileage for a vehicle. And the way this typically works is a customer fills up tank, or records mileage when the tank is filled up, drives until it gets low enough where it needs to be filled again. It really doesn't matter how low the tank gets. Basically, they go to fill up at a future point to the top again, and they record how many gallons it took to top it off. And you also need to get the mileage when they refill. So basically what you end up with is the starting miles and the ending miles. You can subtract the two to get how many miles they drove, and then you can look at the gallons that were needed to fill up the tank, and you can just divide the miles by the gallons. So I went through kind of verbally how you would calculate a gas mileage, and this is something you do kind of in your head, or you might write it down, but you probably just would do this in your head, and so you would just record the numbers and do the math yourself. Now, to get a computer to do this is a little different, because we have to spell everything out very explicitly and run it through step by step. So the problem here up on the screen that I typed in, it says calculate the gas mileage for a vehicle. The customer fills up the tank, records the mileage. Drives, fills up the tank again, records the gallons used, and records the mileage. So knowing all of that, we can calculate the gas mileage. Now, it might be that all you get for your programming challenge is this one statement: calculate the gas mileage for a vehicle, and then you have to figure out an algorithm. So you may not get all of this detail in advance. But in looking at doing an algorithm for this, we would list all the steps that we need to do to make this gas mileage calculation work. So what I'm going to do here is I'm going to put as our first step to ask the user for the mileage of the vehicle, and we want this to be when the tank was last filled. And we're going to assume that the user will have done this previously to running this program. So we're asking the user for the mileage of the vehicle when the tank was previously filled. Let's just put it that way. Then what we want to do is ask the user for today's mileage. Then we need to know the gallons used, or gallons it took to fill the tank today. Let's just say that. So we know the starting and ending mileage, and we know how many gallons it took to go through those many miles. So that's it for the input stage. Now step 4 would be a processing stage, or step I should say. Calculate the miles driven by subtracting ending miles from starting miles. And I guess we could say, we could put in parentheses just to indicator the ending miles would be step 2, starting miles would be step 1. Calculate the mileage by dividing the miles driven by the gallons used. And then finally, we get into the display part of the program, the output process, display the miles driven, the gallons used, and miles per gallon to the user. So, steps 1, 2, and 3 are the input phase, 4 and 5 are processing, 6 is output. If we're going to make an IPO chart for this, your input variables would be the starting miles, ending miles, and gallons used. Processing, we're going to have miles per gallon equals miles driven divided by gallons used. Now, actually, we need to do 2 calculations. And so what I'm going to do here is reformat this a bit. The first calculation will be miles driven, and it's going to equal ending miles minus starting miles. Output, we're going to display the, well, I'll just put all variables. Okay, so the number of ending miles is going to be greater than the number of starting miles, and so the difference between the two is the miles driven. That gets plugged into this equation where we divide by gallons used to come up with our miles per gallon. So a fairly simple algorithm with a pretty clean set of steps, and we've got our variables listed here. The math is pretty easy. It's just a subtraction and a division. I will say that sometimes the math can be a challenging part, and if you didn't like story problems in algebra, which I didn't either, that can be the frustrating part. But usually it's more of a way of it's more of a challenge of thinking logically through a problem than it is dealing with specific math. But that being the case, we have our algorithm here, we have our IPO chart, so we have a good feel for what we need to get, what our variables are going to be, our calculations. So at this point, we're ready to dive into Small Basic and start writing some code. So let's head there next. Okay, so I'm in Small Basic at this point, and what I'm going to do is take my steps in my algorithm, and I'm just going to take and paste them in to the application here through the clipboard. And I'm going to convert each of these tasks into comments. Now in Basic, a comment starts with a single quote mark. So I've converted all these over as you see. And then what I'm going to do is at the very top, I'm going to put the title of the program, who wrote it, the date, and the purpose. So something like that. Then what I'm going to do is take each of my comments and just break them up like this so that there's a space between each one of them. And then I'm going to start filling in the blanks, so to speak. Oh, I'm just going to put a little hyphenated thing up here. It just makes it look kind of nice. Not a big deal. Something like that. Okay. So, the first thing we need to do is ask the user for the mileage of the vehicle when the tank was previously filled. So what we need to do is put a question out to the user on the screen. Now to do that, we use the text window. So type in text window dot right. Now there's a right and a right line. The right line will put a carriage return after the statement that I pass into it, the text that I pass to it. We don't want that to happen in this case. We want the cursor to stay on the same line because we want the user to answer the question on the line it was presented. So instead of using right line, we're going to use right. And what you do is you put the open and close parentheses followed by 2 sets of quotation marks, and then inside of those quotation marks you put your question, which in this case it'll be how many miles did the vehicle have last time you filled the tank. So there's my question. But this is a two-part process. To get input from the user, you have to start by asking them the question, and then the next step is you have to get the answer from them. So I need to get the answer, but I need to store the answer in a variable. And the variable that I'm going to choose will be starting miles. Now, when I name a variable, I'm going to use a notation called Camel Case. And the Camel Case notation doesn't put underscores between words in a variable. As you know, a variable cannot contain spaces. So what I do, instead of putting an underscore between starting and miles, I put the lowercase letter first for the first word, and then every subsequent word I capitalize. And then I just put all the words together with no underscores or any other symbols between them. So we have starting miles here. Now if the variable is just one word in length, then it's all lowercase. So starting miles equals. Again, I'm going to go to the text window, and to ask for input, you have a couple of options here. We have read and read number. In this particular case, we want the user to enter a number, so this is the one that we want. So I'm going to choose read number, and that's it for our first task. So now we have the user entering a number, and it's stored in this variable named starting miles. Now for today's mileage, we're going to, again, bring up a text window. Oh, one more thing I just want to mention here, going back here to line 9. At the very end where the question mark is, I'm going to add a space there, because when the question comes up, I want to have a little space here between the question mark and the response. so that the user has a little bit of breathing room. I mean, there's no point in cramming the two things together. So that's always a good idea to do that. So here's my next question. How many miles does the vehicle have today? Space, quote, parenthesis, like that. Now this variable I'm going to call ending miles, and I'm going to set it equal to text window dot read number. Again, because I'm getting a number from the user. The next question asks the user for gallons it took to fill the tank. So text window dot write how many gallons did it take to fill the tank? Space, quote, parenthesis. And again here, I'll call this variable gallons used. And again, this is a read number. Again, all these are numbers here, so we're using read number for everything. Now that completes the input part of the program. Now we transition to the calculations. Now there basically are two calculations we need to do. The first one is to calculate the miles driven. So I'm going to say miles driven equals ending miles minus starting miles. Now, when it comes to displaying the output to the user, what I'm going to do here is use the write line command. And basically the way this works is you put in quotation marks what we call the literal string, or what you want the user to see. So I can say here, the vehicle was driven Now what I want to do here is notice the space after the N. I want to do something called concatenation. Now concatenation is when you tie or connect together different pieces of something. And what I want to do here is I want to take and concatenate the miles driven into the string, so that the string will say on the screen, it will say the vehicle was driven 260 miles, or whatever it is. Whatever miles driven is equal to, the number is going to be plugged in to that place between the plus signs and included in what the user sees on the screen. That's why I put a space after the N here and another one in front of the M, so that when these are all hooked together, it'll look right on the screen. I'm going to do the same thing for the gallons used. The vehicle consumed whatever that number is, gallons of gasoline. And then finally, the gas mileage during this time was, and I'll put in miles per gallon, and then I'll say miles per gallon. So there's my program. I begin by asking the user for the mileage of the vehicle and record that number in starting miles. ask them how many miles the vehicle has today, record that into ending miles, ask them how many gallons it took to fill the tank, put that into gallons used, and then do a couple of calculations to get the miles driven and then the miles per gallon. And then I output the data back to the user by way of 3 sentences, each of which has a number inside of it. So I'm going to test this thing out and hit the run button, which is this blue button here. I'm just going to click it. Okay, so the first question comes up. How many miles did the vehicle have the last time you filled the tank? And we'll say 20,000. How many miles does the vehicle have today? We'll say 20,310. How many gallons did it take to fill the tank? We'll say 12 gallons. Then it tells us the vehicle was driven 310 miles with 12 gallons of gasoline consumed. The gas mileage during this time was, and then we get this 25.83, this ridiculously long number, miles per gallon. Now, we need to make some changes to the aesthetics of this program. It doesn't really look very good at this point. So the first thing I want to do is shorten up that first sentence a little bit. It's kind of long and wordy. Then I want to put a space between the input and the output sections. And then we have to deal with this really long number. So let's start with the first one, the long question on line 9. Let's change this to say, how many miles did the vehicle have at last fill up? A little simpler, makes a little more sense. Next issue, putting a space between the input section and the output section. Now, of course, the processing section, they can't see that, so we needed some space between input and output. So what I'm going to do is come down here to text window dot right line, and I'm just going to do something like that. Text window dot right line with parentheses. Now this means that you're not passing anything to the command, and that basically is going to print out a line of empty space, which is exactly what we want. We want to have a little bit of space between the input section and the output section. I'm also going to, at the very last one, I'm going to say the gas mileage is, just to make that shorter. Now, what about the issue of this miles per gallon and having this thing coming out to a ridiculous number of digits to the right of the decimal? Now, depending on the number, that may or may not happen, and obviously in this case it did happen. So the question is, how do we deal with that? So what we'll do in this case is we'll round the miles per gallon off so that we don't see the decimal part of the number. And the way that you can do that is to use the math.round command, like this. So instead of just concatenating a simple number like we did in this line and this line, here we're taking the miles per gallon and we're going to the math library and we're rounding that variable, well, what's in the variable, the number, okay, off. We're rounding it. So we're rounding that number off to the nearest integer, and that way when we display the answer, we won't see any decimal places. And that's a pretty safe thing to do in this case because the user probably isn't going to care if they get 26.1 miles to the gallon or 26. Now, in a future video, I'll talk about how to present money values or whatever other values where you do want to round them to a particular number of digits to the right of the decimal. But in this case, let's just give this a shot the way we've got it here. Oh, I'm getting an error message on the text window.write line. When I told you could just put the parentheses in with nothing in there, I lied. You do have to give it something. And so what I'm going to do is just put in 2 sets of quotation marks. And that should do the same thing. Most languages let you not put anything in, but with Small Basic, you have to put the double quotation marks in. No big deal. Let's try it again here. Okay, so we've got 20,000 as a starting mileage. 20310 is our ending mileage. 12 gallons to fill up the tank. And then it says the vehicle was driven 310 miles, consumed 12 gallons of gasoline. The gas mileage is 26 miles per gallon. Much nicer. The only other thing I'm going to do is put a space between press any key to continue and that last statement. Now, press any key to continue is part of the environment. We don't have any control over that. But what I can do is put one of these guys in at the very end just to give it a little bit of space. So here's what will happen. And I'll use some different numbers here. Oh, 800 miles per gallon. Pretty sweet. Yeah, okay, I got a little carried away with my miles. You drove 8,000 miles at 10 gallons to refill. Yeah, I don't think so, but it's fun to dream. So anyway, the program is working. Now, you can do a lot of stupid things as a user in this program. You can put in, negative numbers. You can do all kinds of crazy things. And yeah, at this point in time, we're not going to worry about it. At a future point, we're going to get into user input validation so that we can get this thing a little more bulletproof to protect the program from crashing when you get users that are, a couple fries short of a Happy Meal, right? So it's good enough the way it is for this program. We're going to go ahead and leave it here. This is a complete program. When you're doing programs like this, remember to put this block at the top with your title, author, date, and so forth. And again, I took my algorithm and I just took that and split it, and I took all the points, the steps basically, and put them in as comments in my code, and then I just took care of them one at a time. So that's good for this video. Hope this is helpful to you, and I'll see you in the next video. Thanks for watching.